In the year -1 billion, separable equations might not have been here.
In the year 1690, they were here, and you could solve them, and some people solved them.
A separable equation is a first-order differential equation in which the expression for dy dx can be factored as a function of x times a function of y.
Okay, so what does that mean in English?
Well, first order means that the equation only involves the first derivative, and differential equations are those that relate functions to their derivatives. So knowing these will help you recognize a separable equation, which is an equation relating dy dx to f of x times f of y.
Let's look at some strategies to solve these separable equations. First, if you're given a y prime, make sure to convert that to Leibniz form, more commonly known as the dy dx form.
And once you have it in the dy dx form, you can treat it like a fraction. That means that you can cross multiply and divide and do whatever it takes to get your dy and y, or your dx and x, on the same sides.
Once you get your x's and y's on the same side, integrate both sides in order to get rid of the dx and dy. Don't forget to add or subtract c. Seriously.
No.
And now you've added c, you can solve for it if given an initial condition. Otherwise, c remains c even if it has been manipulated, since it's just a constant. Any constant, so you don't know that c on one side will equal c on the other and they won't cancel.
Well, that's great and all, but in order to really solidify this information, let's do a few practice problems. Let's check out the first example problem. We'll start easy. This problem has y prime equal to 3x squared plus 1. We know what you're thinking. Yes, you could integrate the normal way here, but practice makes perfect, so let's get started.
First, we have to change the y prime to dy dx. If we don't, we can't cross multiply and separate the x's from the y's. Easy.
Dy dx looks an awful lot like a fraction. This is probably because it is a fraction. And what can we do with fractions? Cross multiply. So let's get the things with x on one side and the things with y on the other.
Now that we have the x's and the y's on different sides, we can integrate both sides to get y is equal to x cubed plus x plus c. Even though there is a c added to both sides of the equation when we integrate, we only need one c to represent all the constants in this equation, since adding or subtracting constants from a constant still leaves you with a constant.
And don't try to cancel c, or it'll come back to bite you later. And don't forget it either. Please, it's such a common mistake, even if it's totally avoidable.
Hey, what do you know? It's an initial condition.
Brought to you by 6th grade math. Just plug your x, 1, and your y, 5, in and isolate your c value. Seems like we end with y is equal to x cubed plus x plus 3.
Okay, so new problem. Y prime equals 1 plus 1 over y squared.
We'll give you like a 5-second head start on this problem before we explain how to solve it. Pause if you need more time.
Change y prime to dy dx.
Now cross multiply and divide to collect like-ish terms on a side.
And now integrate both sides.
But wait, we can't integrate 1 over quantity 1 plus 1 over y squared. Or can we?
Yes. Yes, we can. But wait, there's more. Order now and you can receive a free negative arctan y plus c with your y. Remember, multiplying by common denominators can be a lifesaver.
Now we have to solve for c, but how would we do that? I don't have any idea as to what c could equal. This is possibly because, there were a grand total of no initial conditions. We actually can't find c here.
Because we have no way to solve for c, we leave the answer with a constant of integration. The final answer we get is y minus arctan y plus c equals x. This one looks like...
Too much work? Yeah, agree. It's still solvable though, as long as you remember the strategies we've been practicing. Strategies that you can practice during the head start we're going to give you right now. First, we have to rewrite the y prime as dy dx.
After that, the equation still looks too complicated to easily separate, but using a few algebraic steps to simplify the right side leaves us with a more separable-looking equation.
Next, by treating the dy over dx as a fraction, we can separate the x's and then the y's so that they are on the different sides.
Again, since we have the x's and the y's on their own sides, we can integrate to get them into a nicer-looking form. Integration would be the optimal place to use your calculator in problems like these. You won't have much use for finding roots, and graphing is pointless, so if you can use it to find indefinite integrals, that's where you'll want it. Doing so will save you the time of doing a u-sub.
The integration leaves us with y cubed over 3 plus c is equal to e to the power of x squared over 2 plus c. There is no initial value for either variable provided for us, so we can't solve for c. We can, however, use only one c to represent the constants of the equation.
We can also isolate y with some algebra, and that leaves us with the answer. Y cubed is equal to 3/2 e to the power of x squared plus c. This one doesn't seem too bad. I mean, the left might not be pretty, but...
Hey, we'll cross that bridge when we come to it. But right now it's time for you to start solving before we explain. We'll give you 5 seconds. First, we have to rewrite the y prime as dy over dx.
After that, the equation looks pretty easily separable. We just need a little bit of algebra.
All we have to do here is multiply by dx, and dy is already in the right place.
With the x's and the y's on their own sides, we can integrate without worry. Simple enough. Again, use a calculator here. Unless you want to integrate by parts, there's no way to solve this using traditional integration methods. Save yourself some time here and solve for the indefinite integral on your graphing calculator.
The integration leaves us with, deep breath, negative x cosine x plus sine x plus c equals y squared plus 1/6 e to the 6y plus c. We can get rid of 1c. Let's arbitrarily make it the one on the left. When we plug in our initial condition, we see that most of the terms disappear and c becomes equal to negative 1/6. Plug that back in and you get this beauty.
And we ultimately can't isolate y here, so it's easiest to leave the equation in this form. That's it for now, guys.
Check out our worksheet if you need any more practice, and leave any feedback or questions down in the comments.
Bye.